Very good morning, dear children. Today we are going to continue the chapter number 2, real numbers. Before we begin with the exercise, we will learn some important points and the points to be remembered. Firstly, we will learn properties of irrational number. Addition or subtraction of a rational number with irrational number is an irrational number. Secondly, multiplication or division of non-zero rational number with irrational number is also an irrational number. Addition or subtraction, multiplication and division of two irrational numbers can be either a rational or irrational number. These are the properties of irrational numbers. Nextly, we will learn properties of order relation on real numbers. Firstly, if A and B are two real numbers, then only one of the relations holds good. That is, A equal to B, or A is less than B, or A is greater than B. Secondly, if A is less than B and B is less than C, then A is less than C. Thirdly, if A is less than B, then A plus C is less than B plus C. B plus C. Fourth one, if A is less than B and C is greater than 0, then AC is less than BC, and if C is less than 0, then AC is greater than BC. Next to be learned is square root of a negative number. Here it is marked. Square root of a negative real number is not a real number. Again, square root of a negative real number is not a real number. Let us begin with the practice set 2.2, question number 1. Show that 4 root 2 is an irrational number. Let us solve. Solution. Firstly, we will assume 4 root 2 is a rational number. So we can find co-prime integer A and B where B is not equal to 0, such that 4 root 2 is equal to A upon B. Therefore, root 2 is equal to A upon 4B. Where do we get this 4? We get this 4 from the first statement, left hand side. From the left hand side, we have there is a 4. When we bring it in the right hand side, it will go to the denominator. Since A and B are integers, A upon 4B is a rational number, and so root 2 is a rational number. See children, in the left hand side, if you see A upon 4B is a rational number. If the left hand side is a rational number, the right hand side is also rational number. Why we are saying the root 2 is also rational number? Because we have written root 2 is equal to rational number. What is that rational number? The rational number is A upon 4B. Okay. This is the first step we have solved. There is an alternative method for solving the first step. Let us see the alternative method for solving the first step. let us assume that 4 root 2 is a rational number. So we can find co-prime integers a and b where b is not equal to 0, such that 4 root 2 is equal to a upon b. I am bringing this b on the right hand side. Okay, in the left hand side, if you see here, we have b in the denominator. When we bring it on the right hand side, it will go to the numerator. So our equation becomes b 4 root 2 is equal to a. I am squaring both the sides and I am making this statement as equation number 1. When I do a squaring, see this step, I have like this, b 4 root 2 square, okay, is equal to a square. B square, 4 square is how much? 16. Root 2 square is 2. This becomes 32 b square. Okay, don't get confused. Where do we get from this 32 b square? Okay, now I am bringing this b 32 to the right hand side. So it will come to the denominator. So b square is equal to a square upon 32. We will write like this. Since 32 divides a square, so 32 divides a as well. So we write a is equal to 32c, where c is an integer. Therefore, a square is equal to 32c the whole square. I have squared both the side. Okay, this is the statement. A is equal to 32c. I am squaring both the side. So since I know that a square is equal to 32b square from statement number 1, so I will write here 32b square in place of a square. So 32c square can be written as 32 multiply 32c square. So when I bring 32 from the left hand side to the right hand side, b square is equal to 32 get cancelled. So I will have 32 c square. Okay, for explanation, the left hand side also I am having a 32, right hand side also I am having 32. So when I bring here, 1 minute. So I am having 32b square is equal to 32 multiply 32 into c square. So b square is equal to 32 multiply 32 c square divided by 32. 32 get cancelled. So I am having 32 b square is equal to 32 c square. So c square is equal to b square upon 32. Where do we get 32? From the right hand side. I brought it to the left hand side. Since 32 divides b square, so 32 divides b. Therefore, 32 divides both a and b. A and b have at least 32 as a common factor, but this contradicts the fact that a and b have no common factor other than 1. Therefore, our assumption that 4 root 2 is a rational number is wrong. We have assumed in the first step, okay, we have assumed 4 root 2 as a rational number. So, our assumption is wrong. Since our assumption is wrong as a rational number, if it is not a rational number, then it will be a irrational number. So, we have proved it is a irrational number. I hope you all have understood. Now, let us do the next sum. Question number 2. Prove that 3 plus root 5 is an irrational number. Solution. So, same. we will assume as a rational number first. So let us assume 3 plus root 5 is a rational number. So we can find co-prime integers a and b, where b is not equal to 0, such that 3 plus 5 is equal to a upon b. I will bring this 3 from the left hand side to the right hand side. When I bring from the left hand side to the right hand side, this plus 3 will become minus 3. So I will be having root 5 is equal to a upon b minus 3. So since a and b integers a upon b minus 3 is a rational number, and so root 5 is a rational number. As I said, the right hand side is a rational number and equal to left hand side. So therefore root 5 is a rational number. Since we know that root 5 cannot be a rational number if our assumption which we have done is wrong. But this contradiction the fact that root 5 is an irrational number. Our assumption that is 3 plus root 5 is a rational number is wrong. So our assumption became wrong. If it is not a rational number, then it will be a rational number. Therefore 3 plus root 5 is an irrational number, hence proved. Now question number 3. Represent the number root 5 and root 10 on a number line. So we have to represent root 5 and root 10 on a number line. Normally we draw a number line using whole numbers. Now we have a rational numbers here, irrational number. We have to plot that irrational number in a number line. How to solve that? To solve the irrational number, so let us solve this. 1 minute. So I have 5 here, root 5. So I can write like this: 4 plus 1. 4 is the square of 4 is the square of 2 square plus 1, that is 4. This becomes 2 plus 1. So in this form, one side of I am going to plot a triangle where one side will be 2, the other side value will be 1. Why I have taken this? I hope you all have understood the calculation which teacher had done here. Okay. So I have a triangle here, children. The triangle name is OAB. OAB, A is 90 degree. OAB. So as I said, one side should be 2 unit, another is 1 unit to get root 5. So according to the Pythagoras theorem, children, OB square is equal to OA square plus AB square. AB square. So OA is equal to 2. So OA is equal to 2 and AB is equal to 1. So we have to first draw this triangle. How to draw this triangle? Let us see. So after solving, you will get OB value is root 5. So let us solve. Okay, I've drawn a number line using a scale. Okay, 1 centimeter, 2 centimeter. I place my point A in 2 centimeter, that is 2 unit, using a compass through the point A to B. Okay, I'll put an arc of 1 unit. Take a 1 unit and put an arc. Now mark it as B, children. Mark it as B. Okay. Mark it as B. Now OB, join OB. OB is my hypotenuse. So OB will be my radius of the circle. So take a distance using a compass and draw a arc or a circle here. Here. Here, the point that intersect on the number line, I'll mark it as C. That point is called as root 5. I hope you all have understood. Refer question number 2 to draw. This is a wrong question, children. This is a wrong question. Question number 2. This is a method to solve question number same question number 3 to draw root 10. Okay, so I'll do small calculation, then see the PPT and solve by yourself. This can be written as 9 plus 1. So 9 square is, square root of 9 is 3 square. 3 square plus 1 square. So this becomes 3 plus 1. Okay, so one side will be 3, the other side is 1. One side will be 3 unit, the other side will be 1 unit, and the hypotenuse is root 10. So refer the PPT I will provide you and draw by yourself. Now question number 4. Write any 3 rational numbers between the 2 numbers given below. I have 2 rational numbers. Between the 2 rational number, I have to write 3 rational numbers that comes between the given rational number. So question number 1, 0.3 and minus 0.5. Here we have 2 methods to solve. Whichever method you find it easy, you can solve by any method. Whichever you find it easy. First method. So 0.3 can be written as 0.30. Okay, and minus 0.5 can be written as minus 0.50. So we have from negative to positive, or you can write positive to negative. So I have written here positive to negative. So from when I write positive to negative, the number keeps on decreasing till I reach the negative number. So my 0.30, after that minus 0.29, 0.27, 26, 0. It goes on till 0.10, 0.5, 0.2, 0.1, 0.0, then minus 0.1, then minus 0.5 till it reaches minus 0.50. So we have so many numbers which I said you can take pick up any 3 rational numbers between that. So I have written here the rational number, the 3 rational numbers between 0.3 and minus 0.5 are minus 0.3, minus 0.1 and 0.1. You can write any 3 numbers. Okay. Now alternative, another method for solving this. So we have to first consider 0.3 and minus 0.5 as A and B. So first step is A plus B divided by 2, that is 0.3 plus minus 0.5 upon 2. So when I do the calculation, I'll get the answer 0.1 minus 0.1. So this is A. A is 0.3, and what the answer we got it just now, minus 0.1. So 0.3 plus minus 0.1 upon 2. So after doing the calculation, we will get the answer plus 0.1. This is the previous first one answer we got, minus 0.1 plus, this is a question minus 0.5 upon 2. After doing the calculation, we will get the answer minus 0.3. So the 3 rational numbers between 0.3 and minus 0.5 are minus 0.5, minus 0.1 and 0.1. This is the second method. As I said before, any 2 method you can solve any one method, whichever you find it easy. One more. Question number 3. 5.2 5.2 and 5.3. 5.2 can be written as 5.20, 5.3 can be written as 5.30. So between 20 to 30, you can write it easily, right? So I'm writing in the ascending form: 5.20, 5.21, 5.22, 5.23, and so on till 5.30. So I'm going to pick up any three rational numbers between 5.20 to 5.30. So the answer is the three rational numbers between 5.2 and 5.3 are 5.21, 5.22, and 5.23. I hope, children, you have understood the sums of practice set 2.1. Go through the videos. I will also send the PPT along with that. Refer it, understand, and solve it in your notebook. Thank you.